Critical values and zones of rejection define those sample outcomes that are going to lead us to reject a null hypothesis in favor of an alternative hypothesis. They are the boundaries of the observed sample data that are going to lead us to reject that null hypothesis. When we establish critical values and zones of rejection, there are three things that we have to consider. First of all, we have to consider whether or not we're talking about large or small sample, and that means are we going to use the z distribution, the normal curve, or the t distribution for comparison standards. Second factor we need to consider is the nature of the alternative hypothesis. Is the alternative directional, meaning greater than or less than some values expected? And if that's the case, we're going to only have one rejection area. If we hypothesize that as an alternative that is not equal to some value, then we're going to have two rejection areas. We're going to have a positive and negative t-score or z-score. Third thing we need to consider is the significance level of the test, or what's called alpha. And alpha defines the probability of making a type 1 error, and we either set that usually in advance at either 0.05 level or 0.01 level. So if we have a two-tailed test at the 0.05 level in large sample, our critical value is going to be plus or minus 1.96. Any value more extreme than that is going to lead us to reject the null hypothesis in favor of the alternative.